Welcome. In this today's SPSS lesson, we will be discussing on reliability and how to measure reliability. In the first phase, we will be referring to Cronbach alpha. This was developed by Cronbach and measures reliability or the consistency. In most of the social science researchers, there are some variables which we cannot measure directly, such as age, that we can directly measure. However, there are some variables, namely latent variables or unobservable variables. So, in measuring such variables, we will be using Likert type questioning. Once you do that, you do the exploratory factor analysis, and prior to confirmatory factor analysis, you will be checking reliability and validity. So reliability will be measured mostly by Cronbach alpha nowadays. There are several assumptions, and these are mainly the assumptions: normality, unidimensionality, and errors are uncorrelated. So we will be discussing last two assumptions mainly. Errors are uncorrelated. If you have conducted any CFA, confirmatory factor analysis, you know that this factor has been contributed by these three. So this one explains percentage of change of this factor, and what is not explained is the error. And in this Cronbach alpha, we will be assuming that there are no correlations between E1, E2 and E3. Next thing is unidimensionality. For an example, we can assume in measuring Cronbach alpha, these will be the questionnaire items or the constructions are being loaded to a particular factor. At the latter part of the video, we will be showing what is meant by unidimensionality by taking an example. So first we will be calculating Cronbach alpha. For that, we will be referring to perceived ease of use variable, and there are 5 question items for that. So we will be selecting analyze, scale, reliability. Then we will be selecting all these PEOU items here. Thereafter, you can tick item, scale, and scale if item deleted, and covariations, correlations, and you can proceed. And under model, you can select alpha. Here you will be getting Cronbach alpha figure 0.863, and these given for standardized items. In some cases, you may be having scales 1 to 7 and 1 to 5. In such a case, they have given standardized item alpha as well. So when you refer here, what is meant by if item deleted, we will explain in a while. Here you have obtained alpha value of 0.863, and even if you are deleting any of these question items under PEOU, you will not be able to increase alpha value. However, imagine that you are having perceived ease of use variable with another question item such as INNO1. So we'll be moving on to this side and we'll run the analysis again. Here you will be getting alpha value 0.837, and under this table you will be getting if item deleted value for INNO1 as 0.863, meaning if you are going to delete this INNO1, you will be increasing Cronbach alpha value. So it suggests to proceed with deleting this INNO value. That's what it means. Next thing is, there are different Cronbach alpha values. However, most of the time above 0.7 are acceptable and above 0.9 excellent. We consider internal consistency is excellent. So, and below 0.5, that is not acceptable. And now we will be displaying what is meant by unidimensionality assumption in Cronbach alpha. If you run exploratory factor analysis or principal component analysis using this one, analyze dimension reduction factor. Thereafter you can select this POU 1 to 5 and you can refer this initial solution, reproduce and KMO, extraction 3.10, this one, extraction based on eigenvalues, rotation Promax, and options surface values below 0.4 like. Otherwise you can proceed with whatever the details available in factor analysis or default details and press OK, and here you will be getting output for factor analysis, and here it is suggesting only one factor to be extracted. So as we assume perceived ease of use variable is contributed by 5 question items. So all those 5 have been considered only for one factor. So that is what unidimensionality means. So with that we will be concluding today's session on Cronbach alpha calculation. Thanks for watching.